Are we about to make like bionic people with this? Because that's what I that's what I think of when I'm reading this. It's just fascinating, really. Alrighty. And in strange science, this comes to us from Science Daily. Electronic skin. Physicist develops multisensory hybrid material. Again, in the realm of creepy. I don't know. I gotta get an ad blocker. I do not care much for the New York Times. Anyway, 3-in-1 hybrid material for the next generation of smart artificial skin. Creepy. Just creepy. Really. Recently developed smart skin is very similar to human skin. It senses pressure, humidity, temperature simultaneously and produces electronic signals. More sensitive robots or more intelligent prostheses are thus conceivable. Okay. Again, creepy. On very many levels. Creepy. I don't know about y'all, but it's kind of creepy. I don't know. Anyway, the smart skin was developed by Anna Marie Kolkleit. Anna Maria Kolkleit, excuse me, is very similar to human skin. It senses pressure, humidity, and temperature simultaneously and produces electronic signals. More sensitive robots or more intelligent prostheses are thus conceivable. The skin is the largest sensory organ and at the same time the protective coat of the human being. It feels several sensory inputs at the same time and reports information about humidity, temperature, and pressure to the brain. For Anna Marie Kolkleit, a material with such multisensory properties is, quote, a kind of holy grail in the technology of intelligent artificial materials. In particular, robotics and smart prosthetics would benefit from a better integrated, more precise sensing system similar to human skin. The ERC grant winner and researcher at the Institute of Solid State Physics at TU Graz has succeeded in developing a 3-in-1 hybrid material smart skin for the next generation of artificial electronic skin using a novel process. The result of this pioneering research has now been published in the journal Advanced Materials Technologies. I don't honestly know. I don't honestly know here because it's just it I don't know. Smart skin just sounds creepy given the amount of smart devices that exist. Um. Anyway, as delicate as a fingertip. For almost 6 years, the team worked on the development of smart skin as a part of Kolkleit's ERC project, Smart Core. With 2,000 damn 2,000 individual sensors per square millimeter. The hybrid material is even more sensitive than the human fingertip. That's not creepy at all. I'm sorry, this is really weird. Strange science is what it is, but awesome at the same time. But think about the amount of sensors and think about how small a millimeter is. I mean, that's fracking small to have that many sensors in a square millimeter. A square millimeter, 1 millimeter by 1 millimeter. Fracking interesting and amazing at the same time. Each of these sensors consists of a unique combination of materials, a smart polymer in the form of a hydrogel inside and shell of piezoelectronic zinc oxide. Kolkleit explains, quote, the hydrogel can absorb water and thus expands upon changes in humidity and temperature. In doing so, it exerts pressure on the piezoelectric zinc oxide, which responds to this and all other mechanical stresses with an electric signal. The result is a wafer-thin material that reacts simultaneously to force, moisture, and temperature with extremely high spatial resolution and emits corresponding signals, electronic signals. Quote, the first artificial skin samples are 6 micrometers thin. Yeah, a micrometer is 1,000th of a millimeter, or a millionth of a centimeter, if you will. Holy crap. If I'm doing my math right in my head, I may not be. Wow. That's the fun part of science. Or, let's see, 6 thousandths of a millimeter. But it could be even thinner, says Anna Marie Kolkleit. In comparison, the human epidermis, which is your skin, is 0.03 to 2 millimeters thick. Yes, depending on where it is on you. Because, like, your hands and things like you use all the time that are going to be, gripping things and need to have more protection, it's thicker there. Like the bottom of your feet, too. The soles of your feet have really thick skin compared to other parts of your body, be it like your chest or your face or what have you. No. Your feet and your palms and your hands generally have thicker skin. For protected measurement, because you're using your hands for a lot of things and you're using your feet for a lot of things. Anyway, that's a whole other tangent. That's an evolutionary thing. The human skin perceives things from a size of about 1 square millimeter. The smart skin has a resolution that is 1,000 times smaller and can register objects that are too small for human skin, such as microorganisms. Just a thought that occurs to me. If this smart skin can register things that are 1,000 times smaller than what you can feel with your fingertip, your actual natural skin, and it can then feel microorganisms. Wow. That's really kind of creepy. It's amazing, but it's creepy at the same time. Material processing at the nanoscale. The individual sensor layers are very thin and at the same time equipped with sensor elements covering the entire surface. This was possible in a worldwide unique process for which researchers combined 3 known methods from physical chemistry for the first time: a chemical vapor deposition for the hydrogel material, an atomic layer deposition for the zinc oxide, and nanoprint lithography for the polymer template. The lithographic preparation of the polymer template was the responsibility of the research group Hybrid Electronics and Structuring, headed by Barbara Stadlober. The group is part of, Jonium Research's Material Institute based in Wise. Several fields of application are now opening up for this skin-like hybrid material. In healthcare, for example, the sensor material could independently detect microorganisms and report them accordingly. So it's like your bacterial detection on a very, very interesting level. It's like you just put this thing down and you can detect that there's bacteria right away. It's very strange, very cool, but very strange. Also conceivable are prostheses that give the wearer information about temperature or humidity, or robots that can perceive their environment more sensitively. Okay, wait a second. Prosthesis that can give the wearer information about temperature or humidity. How would that work? Because, I mean, a prosthesis is a fake limb. But how would that artificial electrical signal from this fake skin get communicated to a person's brain? That would be the immediate question I would have, is how the heck you would do that. But I'm also just like, are we like borderline making bionic people or something? Are we about to make like bionic people with this? Because that's what I that's what I think of when I'm reading this. It's just fascinating, really. Conceivable process. Okay, on the path to the application, smart skin scores with a decisive advantage. The sensory nanorods, the smart core of the material, are produced using a vapor-based manufacturing process. This process is already well established in production plants for integrated circuits, for example. Okay. The production of smart skin can thus be easily scaled and implemented in existing production lines. The properties of smart skin are now being optimized even further. Anna Marie Kolkleit and her team, here in particular the PhD student Tehar Abu Ali, want to extend the temperature range to which the material reacts and improve the flexibility of the artificial skin. Awesome. Creepy. Creepy as all get out. But awesome. I'm just like, part of me is like, okay, A, are we going to make bionic people now? Are we going to make robots that are maybe a little bit too much like people? And, yeah, and the fact that you could, theoretically, I mean, I'm just going off the speculatory ends here. Um, you could make yourself a glove out of this smart skin, right? And then just be able to put your hands down and detect, is there bacteria here, according to what they're saying, because it was up here in the article. If such thing were true, I kind of question. Um, Here's the interesting further intuitive leap that one might take. If this is a smart skin that you can have this glove of smart skin, put your fingertip down here and detect a microorganism, could you thusly get to the point where you are putting your finger of smart skin down on the table and detecting which microorganism that is? If there's, oh, I don't know, staph or heck detect a virus or something on the table. Just a thought. I'm kind of curious. Should be interesting. Let me know what you think. What do you think about smart skin? Would you like some smart skin? Smart skin gloves, maybe? I think it's cool for the prosthesis idea. It would be really, really fascinating. I don't know how you communicate artificial signal of the smart skin to the human brain. That's a whole other question, because they're talking about the people wearing them, not just the robots here, because they were talking about the people wearing them at the end. I don't know. Be curious. Let me know what you all think. I'd appreciate it. What do you think of smart skin? Would you trade yourself in? Would you trade it in and get some smart skin? I don't know. That's it for now. If you like this video, hit the like button on the way out the door, comment on the video, share the video, subscribe to the channel, all that good jazz. Come and join us over on Locals. I'm probably going to do a little bit more behind the scenes there, because I do have one particular article that is of interest that I don't actually want to put up on YouTube. So I'm going to put it behind the paywall there on Locals. Well, not behind the paywall, behind the membership wall anyway. That's it for now. Until next time, I'm Adrian, and I hope you stay curious, my friends.